Should be going live real soon. Here we are. Okay. Cool. Just get everything set up here. I'm just waiting for you, friend, to pull up a little stool. Come sit. Computer chair, whatever you got, you know. Let's program. Let's do some programming. Oh, I gotta fetch some stuff first. Yeah, that's right. Okay, cool. Let's just check our Haskell Slack. All right, yes. Sunday, hope to see you. Yeah, we're going to do some Rosby hacking later tonight. But this afternoon, I'm just chilling out, taking a break from interviewing madness, and going to do a little programming today. So we're going to look at Adventure Engine. I've been thinking a lot about Adventure Engine. In the back of my mind, I had some thoughts for it. I finished the examine command. So if we wanted to try that out, basically, mostly works right now. We got the log messages kind of coming out. Still have to handle log messages. Basically, I don't know if we want to keep them forever, if we want to like clear them out after they've been viewed. But they're there. I'm actually not going to make a to-do for that yet because I don't really know how I want to handle that yet. But what we do have now is one more new command. So we can examine the purse on the floor, and you can see right here the weathered old leather purse that's been sitting on this front porch for who knows how long. Or you can pick it up. We can pick up, say, the shovel, and we can examine my shovel to talk about the shovel in our inventory, one we're holding. And we can see a rusted shovel with a wooden handle. All right, and then if we walk the front door, right, we still see those log messages, right? Because my render functions just renders out the entire state. So maybe there's like a way to, maybe it might be something interesting for the UI of the interface of our program to understand that these have been seen, so don't render them anymore, or optionally don't render them anymore. I'm just going to leave that for now. So, yay, it works. Examine. But the one thing I noticed from the last time we added a new command, so when we added the examine command, is that we're struggling a bit, and we had to jump around to a bunch of different places to implement it. Right. Our first stop usually is to update this data structure here, the command, with a new case. And we mentioned something about some types, right? That they are, when you write code around a sum type, you have to handle all of the cases for it. So they're kind of like they're like a fixed set of commands, and you have to handle all of them, right? And you have to dispatch to all of them. So we have to update things in a bunch of different places for these as well. Like when we're parsing them, parse command here. We have parse input here. So just breaking up the text into the different pieces. Verbs. So the verbs, we have a bunch of validation for that when we parse those. We added prepositions. So when a verb, when a sentence has a little bit more structure to it, a preposition allows us to apply a verb, or maybe put different parts of the parameter to relate different parts of parameters to each other. So one thing I wanted to experiment with is kind of pulling together this pattern. I feel like when I'm implementing a new command, I'm having to jump from that data structure to the parser on the input to the parser of the commands, then back to update here, where we case on all of the different commands that are available. And I feel like this isn't very, it's just annoying to extend. And there's a lot of, because the logic is spread out in a couple different places, we have to be fairly disciplined when implementing it. I feel like there's a better way we can handle this code. Like a better, I don't know if it's a better abstraction, but a different pattern maybe. So I wanted to experiment with dynamic dispatching in handling our commands. Okay. So that's what I think I'm going to do today. Now, dynamic dispatching. That's the idea where, based on some input we get from the user, we're going to invoke some functionality, but we don't know ahead of time what that thing that we're invoking is. Right? We can sort of dynamically configure our application to support different commands. And the reason why I want to do this is mainly so that when we're writing new commands, we can just write it in one place and hand it off to the game engine. And the other cool thing I think that will come down the line from this pattern is that because we dispatch at runtime after parsing the input, we have the potential to add new commands while the game progresses. So you can imagine picking up an item that gives you new abilities, like maybe picking up the shovel will allow you to thwack things in the game world with it, or dig, and gives you a new dig verb, right? Whereas with this pattern right here, we'd have to handle the dig command, but then we'd have to look at the state of the world, investigate the user's inventory, their current context of where they are to see if they are allowed to dig. And if they don't have the shovel in their inventory, and that hard codes everything together and really couples it together. Whereas with a more dynamic approach, a more dynamic dispatch approach, we could add that command to the valid commands, or the valid commands that the user is allowed to use at runtime. So when they pick up the shovel, maybe it comes with an associated command that tells the game engine to add the dig command to the valid list of commands. All right. So, dynamic dispatch. The idea, I guess, is that when we get a command as input, right, we have this box, this command. It's incomplete, but it doesn't mean that we can't talk about it. The pickup command, or the look command, or drop, whatever it is. But there's some, so the verb could be inside here. Right, that tells us what command it is. And there's another part to it. When we, like what we're doing here with update, right, is we're executing a command. We're taking a world, some context, a command, and then we're computing the next state of the world. So each command is one case of that and provides its own function here to do that. I think we could pull that up into the command type itself. We could call it like with, or something like that. So with the world, some arguments, we get a new world or a game error. Right? So we get the either error or whatever. And, or do we get, yeah, something like that I think would make sense, right? That function there. Or no. Maybe it returns an invocation. Right, so basically the idea is once we have this command object filled out, it has what it needs in order to execute that command. And the act of executing that command gives us an invocation of that command. And so we go from a command to an invocation of a command. And the invocation is what contains our result. Right, so this has the verb and how to, the function, some f, when applied to some args, gives us an invocation which has the args that were applied and the result, the actual computation. So we can pass these around as an object. We can evaluate them to get invocations which update our game state. That way, our runtime system can then have a list of commands. Right, and so we have a list of valid commands in the state of the engine. And then we can process the input, parse and all that stuff with our text, our input, whatever that is, and look up that list of commands at runtime when we parse the input and say, like, is there a command that can satisfy this input? And that way, that's the kind of dynamic part of this. Right, and so if we ever want to change the state of the engine by adding new commands, we can do that, right? We can always append something to this list of commands. And our dynamic dispatch code won't have to really change because it's just looking up for valid commands in here. Right. And that ties together a few things. That ties together a few things that are kind of spread out in different places here. So hopefully, I think by the end of this refactor, once we try this pattern, I think we'll start to see this kind of come down in size a little bit and be a little bit more manageable. And we'll see our implementations of commands be more like these things here. Yeah. So hopefully that makes a bit of sense. I'm just going to check chat just in case anybody has any questions. Feel free to ask questions along the way as I'm going. I'm just going to think out loud and just kind of go at it for a bit. Okay, so I'm going to go back here and just create a little kind of local branch to experiment with this. Dynamic dispatch. Just to see how this code's going to play out. Before committing to it. So let's go to command. So instead of a sum type like this where we have an exclusive set of commands, we're going to create a new type. I'll call it command prime for now so we don't have to break any existing code. And in command prime now, instead of a sum type, we'll have kind of an open product. So now we can handle many, many different types. We don't have to explicitly list them out here. The command will have the verb in it. It could just be bare text, but I'm just going to keep that with verb in there just to see if that's okay. What else does the command have? Arguments? No, that's the invocation, I think. And with. This is our function type that takes a world. We'll model our arguments as maybe a list of text to the function that handles the command. And that kind of does push parsing a little bit later into the game. So we'll see. We'll have to keep an eye on how that plays out. And that returns either a game error or a new world. Cool. Yeah, I'm starting to wonder actually if there's instances of some type classes we could do for this, but anyway, that's the idea. An invocation then. I don't know if I want it spelled with a K or C, like it's supposed to be proper, but K looks cooler. Invocation of that command, right, is the command or maybe we could just do it with invoke command and some arguments. Which says it's going to be a list of text. And also the result of that invocation. So when we applied it to the world, invoke results is basically the same as a return type from command with, right? Which means this is going to be invocation. This one we could derive quality and show for, I think. No, we can't because command prime has a function in its type. We can't really exactly do that. Okay. Yeah. So that's basically how I'm thinking about modeling it. Then, so now instead, when we take our input and we parse the results, or parse the input, we're going to end up with getting a command out of it. Or an input error. Right, so this is going to take over parsing. So I don't think we defined anything called parse yet. So what does parse take? Let's see, what do we need in order to construct a command? We need a world. We need some textual input. And then we either get input error, or we get a command prime. I think that's cool. The reason why we need the world, well, I don't know if we want to invoke command with to get our invocation, we need the world. But assuming we get our command, process, handle, all right, we have our world, we get some textual input. We get either game error or a new world. Undefined. Super duper. What else do we need? We need, let's see. I'm not sure that we need the world in the parsing stage. Let's see if we can get away without it and implement this first. Okay, so we want to, oh, I know what we need. We need a list of commands. That's what we need. A list of valid commands to search for when we parse the input. Right, because if we're going to return a command prime and construct it, we want to construct it from the list of valid commands that are available. That's kind of like our goal here, right? So let's implement this. Legal commands, input. Yeah. Okay. So we need to split up our input. And the way we've been doing it is we've been doing it in the present imperative tense. We have the verb at the start, the command. So let's continue with that. Let's see, let v and args t.words of the input. No, wait, what am I doing? About. No, we need listed. This will be the command name, the verb, even to look up. Yeah, okay. It's starting to make a little more sense now. The verb, args. Okay. So first thing we need to do is filter the list of list of commands. So if the command verb of that is equal to the verb we get as input, that's the command we want. All right, then we have to go list of commands. No, this is not filter. We don't find. We want to find one such thing. We don't. Do we have find in scope? We don't have find in scope because probably we got a list of data, list of got rid of data.list. There we go. Maybe command. Yeah. That makes sense. Okay, cool. So then we need to go from maybe command to our results. If we have a command here with a verb, let's just case on that for a sec. Case of nothing, just a command. What do we want to do here? We just want to return it, don't we? Yeah, exactly. Yeah. So let's not case on that. I know, I should be using note or something. Invalid verb. Couldn't find a command for that. Too few arguments. Oh, yeah, we got to give it a list of commands. So from legal commands. We haven't used that yet. That makes sense. Thank you, GHC. You the best. We haven't used args. Yep, that makes sense. Yeah, so let's take that out entirely. Yeah, redundant bracket. I know. Okay. So we're just filtering. We're just finding the command based on the verb that we get. So I don't even know if that's really parsing. More as like find get command based on verb. Okay. Right. The next steps, we can get a command out of our legal commands based on a verb. So it allows us to look up. That's our dynamic lookup, right? Next part of it, I want to tie together processing the input line. So the user types in that input line, we got to get the first word out, construct that into a verb, get the command out of our valid commands. Excuse me. And well, that's more like handling, because then I think I also want to actually invoke that command, because we're also going to get the arguments from the input line as well, parsing input line. Or maybe we just get parse just takes the input text and gives us back a pair of verb and the rest are arguments, right? So we split up the input into words, then we have a function from list of that to that. This can fail though if the list of text is empty. This would also be input error. Yeah, okay, that's good. Where we have nothing. Use a generic error for now, if that's even one we have. I don't think so. Unknown input, empty input. Parse command, in the case where we have x and x's, that's fine. We can return our tuple there. So return the verb of x and x's. Oh yeah, redundant binding. CMD then. Okay. Cool. Yeah. Okay, so now I think we have enough to implement our handle, which will combine the idea of parsing the text parameter there into the verb and arguments, looking up, getting the command, and applying the command to those arguments to get an invocation. So we need a place to get that list of commands. So let's, I think world is starting to do double duty for us as not only the game's engine state, but also the description. So I feel like this should be split apart. But for the sake of expediency, or not. I'm gonna start splitting it out here. I think that's probably best. Engine state, game state. So the idea of the game state here, I'm thinking, is that this will be where we have kind of those meta things, like which commands are available. We might even move the log messages over to here as well, and make world. Maybe the world will be a property of here, or we can leave it separate. It needs to be seen if we want to nest the two. This would be a list of command prime. type instead, blah, blah, blah. Thanks, Linter. I'm just going to change it later, though. But whatever. Okay, now we have a place where we can look up the list of commands. So now a handle becomes something like this, where maybe we could use our pattern here. This becomes the verb and the args of parse. Parse what, you say? In the world, the input. Parse the input. Then, assuming that goes well, we get a v and some args. We can get command. And that will be the game state commands of the game. You need the verb that we just parsed out. And that's it. So now we have the command. And in order to return our value here, our invocation, result. Is command with the word of the command that we have applied to the world, the args. And our results then is the results. I'm not sure this is 100%. What's going on here? I wonder if we can mash these together. Right, we have some type errors here. That's because when we're using this monad fail pattern, we have to return the same error here. So we have to basically make our input errors also a game error, or convert. So I have a function that converts from our game error to an input error. That's what this is here. Because parse returns an input error, and command also returns an input error. Okay, so we basically need a function that can operate on the left. I believe there's something for that. Hmm. Isn't there like a bimap? Yeah, bifunctor. Okay. Yeah, we want first. Right? We just want to transform the left, so we can use first to do that. Do I need to import? Maybe I need to import data by functor, or maybe it's in these. I don't know. We'll find out. First of whatever. Yeah. Handy dandy. And then we get a hole where we just have to translate input error to game error. So how do we translate our input error? What kind of input errors do we get from parsing? Basically either empty input or something. So if it's empty input, we should have something in the game error that's basically the same thing. So we could just translate that to const. That should satisfy that. Or maybe we call it missing command. Okay, that's one. Same thing here. No. I'm just applying this in weird ways here. Okay. Now, why is this complaining here? Did I accidentally delete something? Oh, I didn't. What did I do? Yeah, this is supposed to be, sorry, get command. Yeah. And then we do this as well. There we go. And basically, if we don't get a command, we get an invalid verb. This is unrecognized command. We could change that to gain terms. We might even be able to return the user did input so that we could maybe display a more helpful error to say like, I don't understand what you mean by blah, 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 blah. So return the verb back. Verb. That would be command verb of the. No, sorry, that would be the error case, which we're just using. Fix this. Yeah, sorry. Get command, we're using input error invalid verb, which doesn't have a v to give us. So maybe we should change that as well. Because that would be kind of nice. Because then we can use that here. But are we only going to get it? We'd have to case match on all of those, of course. So we could just ignore our input, actually, and just do const again. Because we have the parsed v. So I couldn't match type input error with verb. Oh, yeah. There we go. Okay, so that's cool, that's cool. What do we get here? To go. We get results. Aspect ratio of the chat is a bit squished on the stream. Thanks to PP, and hello. Yeah. If it is, I don't know how to fix it. So if somebody knows a little bit more about that, tell me about it. Because we have this little chat here on the functional programming Slack. We were talking a bit about streaming tips. I'm not very good at the Twitch stuff, so I'm gonna have to figure that out somehow. But if you know, let me know, and then I will fix it. Otherwise, I'm gonna have to experiment with that at some point and try to fix it for you. So that looks better. I noticed that looking back on some of the videos, it's a little bit funky. I just don't know how to fix it. This is just like a web view thing, as I understand it, in OBS or something. And who knows how it's formatting stuff in there. Looks like, I guess it doesn't get any idea about what the viewport size is set to, so yeah. Okay, so let's see. To get a result, we need to apply our command with the command's included function. What's the error here that we're getting? We're expecting to get an either game error invocation. We're getting a function back to an invocation. Right. Yes, sorry, that should be bound with a let. And what's this one? So it's just not enough arguments. Or we got the arguments in the wrong order. Command with takes the world first and then the list of text. Yeah, that should be right. Oh, world is, it thinks world is a function, not a parameter. There we go. Strange that we can't do it with apply. I guess there's something about that. Anyway. Okay, last one here, at least. We're getting nested things. So we have to really match on this. Or just return. Yes, yes, yes. That's expecting magnification. Yeah, yeah. So this means that we just have to get the invoke results of this, right? I'm nesting things. Oops. Oops, oops, oops. Here we go. I am using OBS CPP. Yeah. All right, let me see. So I can right click, transform, reset transform, and then resize the actual window. Right. Okay. I get edit or copy. Chat window itself, yeah. I was hoping to be quite precise with the transform. Hopefully snap guys will be all right. You see how it stretches it, right? So, not 100% certain. Yeah, no. All right, so either I like make it kind of super tiny, but if I stretch it anything like that, you know what I mean? Doesn't quite fit. Yeah, it's just regular Streamlabs, whatever. Streamlabs thing. So, sorry, I don't know. I'll just reset it again. So, sorry, Sabibi. If I can figure out a way with them. Maybe they have a way I can set the size of the box in Streamlabs. Let's check. Let's check that quickly. Why not? I think it hides my secret URLs by default. If not, oh well. Yeah. Yeah. So I don't think you can. I don't see any options for changing the transform here. But it looks like they're rendering in like a fixed size for this chat box for some reason. So maybe I just need to find a better layout for my stream so that I have the width for the chat. Maybe I could just, oops, I could just put in the bottom down here. I don't really use this terminal too much. Let me just reset the transform one more time. Then we'll get back to where we were. Yeah, and then I'll just cook. And get rid of that. And hopefully that looks okay. Well, that's cool. I'm learning things as I go, so here you are. Hopefully that looks pretty okay now. And if everyone likes it, we'll stick with it. It's probably going to be hovering over a blue background for now, at least. That's, yeah. Yeah, I don't know. Hopefully it doesn't look too bad on stream. I can stick a little terminal behind it. Do, 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 do. Da, 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 da. Yeah. Okay, back to it. Sorry, where were we? Well, thanks for your help, SuPB. That's cool. Yeah, I always wanted to get like a better overlay for the stream, just to make it look a little nicer. But yeah, I'm realizing that making things look good is not something I'm very good at. Okay, functional, yeah. All right, missing command, unrecognized command. We're in the middle of handle. We've got, yeah, we just have to update our idea of what invalid verb is. Which can have a verb in it. That's going to break a bunch of our existing stuff. So I'm going to, I think it'll be safe to add another case here. Without breaking anything existing at the moment for now, until I'm ready to start breaking things. And just use that here. Yeah. Fix that. So now it's a redundant bracket. Good. Okay. So now what we have is handle. Let's try out handle. Let's see how that goes. So this, we need, in order for this, we need to have a list of commands for our game state as well. So let's implement like a dummy command prime for that. Default game state. Like that. And our first command will be command prime. Let's just call it the foo command. And handle foo. What will handle foo do? It takes a world, list of text, some arguments, produces an invocation. What kind of invocation will it invoke? To do with the command it was called with. So that means, what does that mean? How do we get that? Oh, there's a way to do it. Right, we'd have to name our command. The foo command. So it's going to be foo and handle foo. And then here we could just do foo command with args and the result. Let's just return pure world. Let's just do nothing. Like do nothing. No op kind of command. That needs to be a verb. So I'm just in like kind of full prototype mode, or I just want to do the least minimal thing possible, even if it doesn't really do anything, just to make sure that the structure of what I'm going for here is going to pan out. And if it doesn't, toss it away, just throw it away. Right, that's what prototyping is all about. Okay. So now I have a default game state. I can handle my foo. I can invoke it, which should just do nothing. So let's load that. Okay, handle default game state, default world, or text, or input text. Yes. What do we get? Oh, Haskell line implements handle. Okay. Call that handle prime then. Haskell line, thank you very much. Reload. Try that again. With handle prime. Because we don't have text overloaded strings enabled. There we go. Okay, let's just make sure that it's actually working. Pure world, let's just update something in the world, like the log messages. The log messages of the world combined with hello from foo. That should be good. Again, what the heck, yo? I have overloaded strings enabled. But a I can't figure it out. That's supposed to be text. Oh, okay. Duh. Sorry. Yeah, sorry. That was a me. That was a me. Okay, we got hello from foo in our log messages. Okay. Yeah. So what do we think about this now? Well, I'm not sure if what we really get from the invocation idea. It just seems like a little redundant. But what I do like about this is that defining our commands now, instead of updating that sum type and stuff, we can define them as types here like this with their handlers. And then when we're constructing the game, initializing the game world, we can decide what commands are available at the start when we configure the game state. And then, like I was saying at the beginning there, we could dynamically add more commands to the game as the player progresses through our game. So that's kind of cool. Do we really need do we really need, though, the invocation? What does that get us? And could handle be simplified? All right, because what if instead of an invocation, handle foo, we change this to just our either game error or world directly, and command with. We don't need invoke results. This returns game error. Either game error or results. World. We don't need that anymore, or that. That. Oh, what do we do here? We don't even need that. We don't even use the argsins command. Although some commands might. Okay, cool. And then I think handle takes care of all we need to do, really. What else can we say about this code? Well, the other thing that I was kind of, I see with this as well, is that we're pushing down what to do with the arguments to the command handler itself. So how this function handles the rest of the words in the input is going to be handled here, which may spread out things here. Right, kind of like to the leaves of our thing. All the action handlers can interpret that list of text however it wants. So the uniformity of the grammar, the input grammar, is kind of good because we're not parsing it up ahead of time and breaking it up into its pieces. This is very, very dynamic, which might push some of the some of that out to here, which means some of our handlers could get, I don't know, they could get pretty complicated. Like what is well-formed input is sort of decided after we handle just that first verb. It's sort of decided by the handlers for that verb. But I think that's kind of the consequence here of our dynamic dispatch architecture. But the bonus we get is that, yeah, that dynamic action of being able to add new commands at runtime. Configure our default set of commands when we start up our game engine, which would give game authors a little bit more flexibility as well when designing their games, and us when we design the game. So, and it also kind of unifies a single place for us to put together the game commands and parsing and things like that. So I think I'm going to stick with it. Yeah. I think I'm going to stick with it. I think we're going to end up seeing a bunch of our input handling code and dispatching code greatly decrease in size. We'll end up pushing some of the complexity for handling the arguments to our verbs down further along the line instead of parsing them up front. But I think that'll be a benefit in the long term, because then we won't have to really uniformly parse we won't have to like come up with a really complicated handler for all our grammar for the inputs. Right, because in our old code, we were parsing inputs, which was pulling out the pieces of the sentence, and then interpreting commands from those inputs. Which this didn't change so much as we're adding new commands. Just the idea of the preposition, right? Which was so that we can interpret one particular kind of command, which was the examine. But now, for example, if we were to implement examine this way, with this more dynamic handler, we would basically implement examine here, and examine would also have to parse its arguments, and handle those cases where we're examining the input from the inventory, or we're examining the item from the inventory, or we examine the item in the room. All right, so instead of parsing, right now we're kind of parsing that ahead of time. When we get the examine command, we examine if there's a preposition in the input. Then we interpret it either as the examine room command or the examine inventory command. Which I kind of like in some ways. Right, but it does make our command type quite large. Whereas when we take the more dynamic approach, we can still split it up so that it's readable into small functions, like an examine inventory function, examine room function. But then the handler for the examine command just has to do that interpretation for us based on what it finds in the rest of the argument inputs. So it's just kind of pushing this upfront code down the line so that our parser becomes a lot simpler. Oh, we split up our parsing. The upfront parsing becomes simpler, but also importantly, the update becomes a little bit more smaller. We do update, we don't have to branch on every command. We can just dynamically dispatch to a list of commands. Yeah, so we're trading flexibility for a bit of moving a bit of complexity around. So I'm going to stick with that. I think that's good. Okay, so the next step in a refactor like this then is to start breaking stuff and removing all the other things and putting our new system in place with our current framework. All right, so updating our REPL to use handle instead, introducing the game state is going to be another thing. And yeah. Do.org, that's one. Pop up. And then yeah, we're gonna have to migrate our input handling code to this new structure, which should be pretty close to what we already have. Yeah. So we have to get that one done. However, we also have to do there's going to be we're going to have a few of those. Oh. We're going to have to migrate walk, drop, pick up, look, and examine. And then we got to add handle prime to our REPL. Yeah, and I think once we knock those things off, we should have things split apart, and we can delete the old code that is no longer being used. And then we can compare it to our master branch and see if our new design actually results in smaller code. Or maybe we pick up a little bit more code, but we'll see. Okay, so our loop, our game loop, our REPL loop. Where are you? Yeah, REPL. So our REPL now, in order to, we have a to-do to add the game state to that. We don't use G yet, but we're going to. We might actually really simplify here, perhaps. All right, so our input T comes from Haskell line, and that's what handles the actual input-output with the terminal and does all the read line stuff for us. When we get to the parse line step, this is where we can simplify stuff down here. Okay. So in the case where we have raw input, then we don't need parse line anymore. I think this is the good place where we can split off our old code to our new code. Call these like split points or things like that when I'm refactoring stuff. This seems like a good place to start. Because our handle prime, right? It just needs the game state world and some text, and it actually does all the parsing stuff as well in here. It turns it all into game errors or new worlds. So handle prime right in here. Game state worlds and raw input. And we have two cases to handle here. Either we get a game error or we don't. All right, so if we get a game error, we output it and we loop again. That's cool. We don't get a command anymore. We get a new world. Already handled for us. Not look. We can just go right into loop. It doesn't like raw input. Oh, because we have to convert that to text. No problem. Okay. All right, so we've cut off our old code path here. We're just handling the input with our new handler. And at this point in time now, if we try to build and run this game, we should get it to respond to only one command at this point, which is our foo command. So let's try that. Oh, right, of course. We forgot to update that part, which is in a completely different file. The actual executable needs to initialize the game state as well. That's no problem. That's just over an app. Main. Default world. Default game state. Dope. Adventure engine. Okay, still rendering the world. We should no longer have walk as available. Unrecognized command is the expected output here with our verb, which is kind of cool. Nice. We should have a foo though, right, which does nothing. Cool. And Kawit should still work. Awesome. Maybe one way we could just make sure that we actually are doing stuff again. Right, why didn't that work again? Probably because, yeah, we do kind of like a re-render when we get a new state of the world. So let's just go back to the REPL there. Just to show how the world changed, if it did. Sterling with our render of world prime. What did I do? Oh, right. Initial render could return an error. That's right. So in that case, we do have to have one more match here, or gosh. Yeah. So we probably didn't. Maybe we lost a bit of code. Anyways, left render error. Something in the case of right. Rendered. We can output that. Right, rendered needs to be t.unpack. To go. Yeah, like the staircase or the Christmas tree of doom. Something like that. It does kind of march to the right. There might be ways later on to fix this. But it's only one place in the code so far, so I'm not too unhappy with it. I'll get to it. But in the case where we get the render error, we'll just output that. Probably the show of it. And the world's prime again. Yeah. Yeah, so it doesn't look like, I don't think we've lost a whole lot of code by doing this, at least in the REPL area, mainly because of the render stuff. But we'll check that in the diff. Okay. Let's just build that. Yeah, Haskell's pretty nice so far. I haven't tested it on Windows, but it does claim to be pretty cross-platform as well, so you're not depending on GNU readline or C implementation. That's like OS specific. So there we go. And we get the foo command and hello from foo, right? Yeah. But we don't understand anything else yet. Cool. One thing we did have though that we need to preserve that I'm just remembering now is the short. We had the ability to match on shortened verbs. I think, how do we do that again? We used prefix of, I think. Yeah, and the smart constructor of verb. We use prefix of as input matching. So I wonder, we need to make sure we maintain that as well. Oh, it does go over the REPL window. Dang it. Of course I forgot. Hopefully I'll stop making that mistake. Okie dokie. So I just wanted to make sure that we have that. So we knock that out and that one. Prefix match. Input. So what we wanted to be able to do is that when we look up a verb, probably when we parse, we just want to do a prefix match as well. So not just only finding an exact match, but if V is a valid prefix of C. In that case, I think what I'll do is pattern match this out here and here. The C verb and whatever else. We don't really care about the other part. And the function, instead of equals exact match, what we'll do is we'll do prefix of, and is V a valid prefix of CV? Is that not the function? Is prefix of, sorry. Yes, GHC, that's what I meant. Right, and we have to match that. V prime, fine. Do it V prime this way. And it's a little dirty, but it works. So we should be able to get, like we had before. So instead of calling foo with full, we should be able to call foo with just F or FO. And get the same thing. Yeah, so we do. That's good. As well as foo. Too many O's and an R. No good. That's good. Okay. Check mate. That's good. What next? I think we just need to port over the commands. And hopefully everything else will be good and just wrap up nicely. And we can start deleting code. Okay. So foo is a good handle test case. Let's just we'll get rid of it in a second. Okay. It's not an exit PP, don't worry. It's fine. Try and make it a little bigger. Not at all. So don't feel like interrupting me or asking questions is ever a problem, because I like my peeps, I like my followers, and it's cool, man. not a problem at all. Happy to help. Okay, yeah, so just as before, just in case you couldn't see that, we have the ability to type in foo, but we can also just type in fo, or we can just type in f and still get that short name prefix match functionality we had before. So the last step now is to start migrating over our command handling code to this new structure, and then we can start deleting code and renaming things as we need to, and cleaning up from our refactor here. Okay, so let's do walk, I guess. Yeah. Mm-hmm. Okay, I think we're going to learn some things while we're porting this code over. Because one of the nice things about parsing up front, of course, is that we can push the requirements for our inputs to the walk2 function away from the implementation of walking2. Right? That parsing code's handled somewhere else. Whereas now we're going to get just a list of text. Right? And we're going to have to pull out the entity ID of the exit that we want to walk to out of that list of text. Right? And also, if walk2 doesn't, our new version of walk2 doesn't understand what the user tried to pull in, we're going to have to tell the user about it through our game error type instead of our input error type. So game error might get a bit, maybe not a bit bigger. Maybe it'll stay the same, but it might get a bit bigger. Who knows? We might have to add another case to it or something. Okay. So with that in mind, walk2 becomes walk2 prime, becomes command prime. Right, and it's a verb, walk, and a function. Maybe we could just write it in line 2. Handle walk. Right, handle walk takes world, a list of text arguments, and returns either a game error or world. Okay, pickup. Same thing. I'm going to avoid deleting the code for now and just kind of do it this way so that everything just stays compiling. Pickup prime. Pickup. They're all going to have the same type. So let's just create an alias. Command handler. There we go. Pickup. And look. Drop. And examine. Sorry, drop. Examine. Cool. Normally I wouldn't type this all out manually, but I've been very, very lacking in porting over my Emacs config to this WSL2 environment because I'm busy or lazy. I can't really tell anymore. Pandemic vibes. Okay, so we've created our seam where we've cut ourselves off from the old code. Now we're just porting over our command handling code. This is looking pretty nice. We just have to provide implementations for each of these. We have most of this. The only thing that's going to be a little bit different with these things, let's see. For example, with handle walk, I think a very common case for some of these are going to have to handle actually. It doesn't matter what world we have, but for walk, if we have empty input, then we already know we have a game error. Right, we have